Parts Express, the #1 source for audio, video, and speaker building components.
Hi, this is Mike with Parts Express, and today we're going to discuss designing a proper box size according to the teal small parameters for drivers on partsexpress.com using Harristech's BassBox 6 Pro software. If you go to our website, up in the right hand corner we have a search box. One of my personal favorites is the Titanic 15-inch Mark III, which is 295-420, and then click on the search button. That brings up the product page for the Dayton Titanic 15-inch Mark III subwoofer. If you scroll to the bottom, what you're going to see are a whole bunch of specifications that determine the proper box size. Most of these specifications don't mean anything on their own, but when you use a program that we sell, such as BassBox 6 Pro, determining the proper box size is made quick, easy, and highly accurate. In order to use BassBox Pro, we open up the program, open up the driver design parameters, and feed in the specifications that we saw on the previous product page. We start with the FS, which for this driver is going to be 24 Hertz. We move to the QMS, which for this driver is 6.75. We move to the VAS, which for this driver is 5.46 cubic feet. Many drivers on the internet are listed as liters under VAS. BassBox offers the ability to switch whatever measurement is being used over to something else. So if you input cubic feet, you can actually switch that to liters if you like. But I'm going to move it back to cubic feet for our purposes. Next is Xmax, which for this driver is going to be 20.5 millimeters. And then we're looking at the diameter. The diameter is going to be measured from 1/2 of one surround to 1/2 of the next surround. I estimate the cutout. That's right there, and it's fairly close. So in this case, that's going to be 14.0125. But that's going to round it off anyways to 14. So 14 would be close enough. We're just trying to get a very, very close estimate. QES is 0.52. The impedance is 4 ohms. And the QTS is 0.49. Once you have these parameters entered into the software, you can hit calculate all, and that's going to bring up every available parameter that's estimated for. Then we input the working power. In this case, I'm working with about 500 watts, and then you hit accept. And again, I'm running in expert mode. I highly recommend running in expert mode whenever you use BassBox 6. Then we bring up the box parameters. For home theater, I recommend using a sealed box. BassBox calls this a closed box. I'm not one of those guys who uses a lot of fill or damping material, so you could select minimal for my purposes. If you want to use heavy, you can of course select heavy. I found that sometimes this has more an effect, where in the real world it's not going to affect it nearly as much as BassBox wants to assume that it will, so that's why I always select minimal. Once we have that input, we can find out what the suggested box size is. Now you can also change the shape of the box at any time to anything you would want to use. For my purposes, I'm just using a square. So I hit suggest. I select high fidelity because I want this to be most linear. You can select high output if you want a bump, and that's more useful for pro audio applications. I select high audio, I select high fidelity, and hit accept. So this is going to determine my box size. Basically what I'm looking at is 3 cubic feet of internal airspace, a QTC alignment of 0.707, which is going to be a trade-off between maximally flat, which is 0.5, and a high Q design that's going to have a bass bump. High Q designs are typical of your boombox systems, so people try to go in between somewhere, and 0.707 is the most accepted alignment. That's going to yield an F3 of 40 Hertz. The F3 is going to be the 3 decibel down point, otherwise known as the half power point, and gives you an idea of where a speaker starts to roll off or what it's going to be usable down to. What we have here is going to be the internal dimensions of 16 by 16 by 20.83, which is actually 20 7/8. You can change that to external and punch in the thickness of the material that you're going to use. For a subwoofer of this size, a lot of people would choose 1.5 inch material. So you change this to 1.5. You can also make this more square by playing around with the A and B dimensions until you get something that's close to the C dimension. So you would increase this and increase this, which is going to decrease this. You can play with this for as long as you like until you get a box that's going to be very close to an actual cube. Once you get close to the box that you want to use, hit plot. Plot is going to give you all of your usable information as to how the speaker is going to work in a particular box size. The normalized amplitude response is going to give you your power specifications in terms of what a speaker is going to do in terms of output. By power, I mean acoustic output. What I'm showing here is that the minus 12 dB down point is going to be at 20 Hertz. This is pretty usable inside of a home because you're going to get a lot of bass boost just because of the dimensions of the room. And this could reach all the way down to as low as 20 Hertz. The F3, like shown on the design window, is 40 Hertz. And that's duplicated on this screen as well. That is duplicated on the normalized amplitude response window. That's what this window is good for. And then what we have here is the custom amplitude response that is in relation to the input power. This is going to be where you would determine your max output in terms of acoustic power. By acoustic power, we're measuring everything in dB. So this speaker can actually output up to 116 dB in this enclosure with 500 watts of power input. The next important tab is going to be the cone displacement. This is where we would monitor the driver to see how it's acoustically moving inside of the box. As long as you do not see any shading, this speaker is going to be well within its built Xmax, which means it's going to stay linear, it's not going to ping, it's not going to bottom out. Using this speaker in this box with this much power will not damage the speaker. However, if you change the input power to something crazy, we'll say 5,000 watts, you'll see that the Xmax is exceeded fairly early at about 45 Hertz. And you can move your cursor with the left and right arrow keys to see exactly where that's going to occur. So basically we're running out of Xmax at 45 Hertz. We don't have to worry about the vent velocity because this is not a ported enclosure. However, you can also look at the impedance data. This is going to show you where the FS of this system is going to be. Basically, the FS of this system is going to be centered right at around 38 Hertz. That's going to be the maximum impedance load that the amplifier is going to see. If you were to add stuffing to a box, this would be minimized. Going back to the damping screen, we could go back and select heavy and replot, and as you would see, the impedance has been reduced. Let me change the color so you can see that more clearly. Again, I do not assume that this type of stuffing or this amount of stuffing is going to have this effect. That's basically it when it comes to a sealed box. What you're looking for in terms of a design goal is going to be a low F3, and you're going to want to stay within Xmax according to your input power.
Click the link in the description for the next part of Mike's software demo.